To better understand the access modifiers, first we need to focus on understanding the applications and namespaces, classes, and assemblies. And since the milestone of any application is the class indeed, so I'm gonna begin with two simple classes just to give you an example of the architecture of the application. So let's assume I have the console class, which has the console read line and write line, and the string class, which has everything to do with strings. So this is class 1 and this is class 2. And I could have like 100 more classes. It doesn't really matter. The combination of all the classes form the namespace. So this is a namespace. And this namespace is called the system namespace. Okay. And if I have another namespace, namespace 1, and let's say that this is namespace 10, for example, and this namespace has from class 1 to class 100. So the combination of all these namespaces form what is called the assembly or the library. I'm just going to use them interchangeably so you don't get confused. Assembly is the library, okay? It's usually .dll, which is dynamic link library, or .exe, which is an executable file. So let's assume that this is assembly 1, and presumably I have 20 assemblies. So assembly 20 .dll, okay? And all the assemblies have the same structure. So the combination of all assemblies I call the application. Alright, so assume that this is called my application, like this application is called my application. Okay, so now if you go to this class, and this is of course a system defined class, but I'm just giving you a hypothetical example. Let's assume that you defined this class and you define the methods or the fields inside this class to be public. Then the content of this class will be accessible within the whole application, including the different assemblies and the namespaces. However, if this class, the let's say the fields or the contents of this class are defined as private, or one of them is defined as private, then it will be accessible within this class itself and not from outside the class. And let's assume inside another namespace a class or the content of this class is defined or are defined as protected, then they'll be accessible from within this class and all the derived classes. And I'm going to explain to you what derived classes are so you know exactly how to deal with protected access modifier. Now, in any derived class, we have a parent class, which is the class to be derived from, and this parent class, I'm just gonna give you an example of a parent class. Let's call this vehicle, since we are explaining the cars. So this is vehicle. Any vehicle in the world will have model, make, color, engine, and so on, right? And I have a car, I have a truck, and I have a bus as well. Okay. Now, all of these vehicles, they are all indeed vehicles, so they share the same thing. They have the model, they have the make, and they have the car. Each one of them has separate model, make, and color, but they all share the attribute of having model, having make, having color, right? So they're all derived from this. So I don't need to go ahead and declare these fields, or if there is a method called to accelerate, for example. Any vehicle can accelerate, any vehicle can stop, right? So they're all derived from here. So if I define them all as protected, or one of them as protected, that means I can access it from within this class and from all the derived classes. However, if you come to the car, for instance, the car can be convertible, right? I haven't seen a truck or a bus convertible, unless it was like a tourism bus. That is something else. But the convertible will only exist in the car, which is called the child class, right? And if I define this as a private, then it will be accessible only from inside the class. And the truck could have more than one axle, or for example, it could have container size. And if I define this as private or protected, then it will be accessible from inside the class and the derived classes. And since truck or car or bus, they don't have derived classes are derived from them, so they will be accessible from inside the class. Alright, and the bus could have, for example, route number, a specific route to drive on. So this is what we mean by derived classes. We also have something called internal and something else called protected internal, and the internal is accessible within the same assembly. So I told you this assembly contains many namespaces, namespace 1 until namespace, let's assume 100, many namespaces, and each namespace has classes, okay, and this has classes as well. So all of them is this assembly. So if I define the content of the class to be of type internal, the access modifier, then they'll be accessible only within the same assembly regardless to the namespace. Okay, so the content of this class will be reachable from this class, but if I go outside this assembly, then they will not be reachable. There's something else called protected internal. What I just explained now is the internal. There's something else called protected internal, and what this access modifier means is the content of the class could be accessible within the same assembly and from derived classes in other assemblies as well. Let's assume I have this assembly 1 and I have assembly, or let's call this assembly 10, and I have assembly 1, and inside assembly 1 I have also the same structure, namespaces, and inside namespaces the classes. Okay, so let's assume that this class inside this assembly is derived from a class in here. Okay, so there's a class here and this class is derived from it. So protected internal, the field inside these classes, or the methods as well, if they're defined as protected internal, then that means they'll be accessible inside this class and all the derived classes in other assemblies as well. So if you declared, or if you defined any class that is derived from this class, whether it was inside the assembly or outside the assembly, they will be accessible as well. Okay, now let's see these terminologies in action.